y represent deflection, theta represents slope or rotation. And so I can read this equation like this. Second derivative of deflection related to x equal moment over EI. E, Young's modulus, I, moment of inertia. It's not a big deal. What is the value of EI? I don't care. I need a final value because EI is a constant, just number. 1,000, 2,000, 1 million, I don't care. So second derivative means I need to do one integration. If you did one integration, you can get your slope, dy by dx. And if you did integration, you can expect constant of integration, constant, C1. If you do another integration, I can get y. Then I will have another constant C2. So we have two constants. This constant can be calculated using something called boundary condition. If you remember last time, supports, we don't have any deflection. We don't have any movement at support. So if you have roller, or if you have hinge, roller, or hinge, we don't have movement. We don't have movement. Movement means deflection. So at any support, hinge or roller, your deflection equals 0. Be careful, guys. Be careful. YA here does not mean reaction. In this topic, which called deflection, YA represents deflection at point A. So I mean YA equals 0, I mean deflection at point A, which is hinge support, equals 0. So any point on the beam can move down or up, except points at support. But if you have fixed support is special. Your deflection is 0 and your rotation also. We don't have rotation. So y equals 0 and theta equal 0 because fixed support is a special support. And also last time we have something called sign convention. For moment, we know to assume a moment, you have to assume your moment to make your member to smile. If you have a positive value for y, that means this point went up. Like this point, for example. If your value of y is negative value, that means your point went down. Like this point went down, or this point went down, or this point moved down. Theta, if your theta is positive, that means it's counterclockwise. And I will let you know what is the meaning of counterclockwise. And if theta equal negative value, it's clockwise. And the last time we covered some steps to solve your problem. The first step, how to calculate your reaction. You have to calculate your reaction first. You have to calculate your reactions first. Okay? Then you have to assume a distance x from your left, then make your cut and derive equation for a moment as a function of x. Do your integration 2 times. You have constant of integration. You have boundary condition. You can solve for your boundary condition. And we covered this example last time. And I will do another 2 examples today. This example, we have simply supported beam. We have a beam AB supported on hinge at A, roller at B, and we have only concentrated moment M. This moment equal 24 kilonewton meter. The length of the beam L equal 8 meter. Can you calculate slope at A and B? Can you calculate deflection at mid-span? Can you draw elastic curve? I'm sorry, what you mean by elastic curve? What you mean by elastic curve? I mean, after you apply your load, the deformation or the new shape of the beam, this curve called elastic curve. So I need to draw this curve at the end of your calculations. Let's start. Anybody can remind me what was the first step? Reactions. Without reactions, you cannot do anything in this course. So I think we have reaction here, probably R1. We have another reaction here, probably R2. We have another reaction here, R3. For example, I don't like to use Y and X because Y in this term or this topic represent deflection. So I don't like to make any confusion. So I assumed my reaction by R. Let's start. Summation f of x equals 0, chapter 2. That means R3 equals 0. If you apply summation f of y equals 0, that means R1 plus R2 equals 0. Remember, does not make any sense to say one of them equals 0. I have no idea. R1 plus R2 equals 0. So probably this one is -5, this one is 5. Probably this one is -10, this one is 10. Probably this one is -1, this one is 1. So I cannot say anything from this equation. I can say summation f of y equals 0. So R1 plus R2 equals 0. That's it. The third equilibrium equation, if you remember, summation moment at any point equals 0. I will take moment at A, and I will assume this direction is positive. It's okay. If you take moment at A, R1 and R3 will be cancelled, but we still have positive 24. M naught will not be cancelled. R1 and R3 cancel because we don't have distance. And we have negative R2 times 8. Reaction R2 times horizontal distance 8 equals 0. The only unknown in this equation R2, your value of R2 will be 3 kilonewton. Wow. So R2 equals 3. That means your R1 will be -3. What is the meaning of negative reaction? R2 equals 3 positive, that means this reaction and this direction is correct. R1 equal -3, that means this assumption isn't correct. Your correct assumption will be down and your value will be 3 kilonewton. And R3 equals 0. Any questions so far? I believe this step, I don't need to cover it in these details, but it's my sadness to see some student until this moment cannot solve for reaction, unfortunately. Second step, assume distance x from your left. So where is the left of this beam? I think your left will start from here. So I will assume distance x. Where? At any location. I don't care. But starting from left. At any location. But starting from left. Can you make a cut at this location? Yes. Can you take the right part? Yes. Can you take the left part? Yes. I recommend to use the left part. where you assumed your x. So I will take the left part. So your section or your part will be like this. I did my cut here. I have reaction here, which is vertically down, 3 kilonewton. I have horizontal reaction here, 0. I have concentrated moment here given 24. At your cut, we have normal, I don't care. We have shear, I don't care. We have moment. This moment will be assumed to make this member to smile. I'm looking for this moment. This is my target. This point is O. So if you take moment at O equals 0, assume this direction is positive. Taking the moment at O will cancel normal, will cancel the shear, and you still have moment. Cannot be cancelled. And we have negative 24. I forget something. This distance is x. 24 will not multiply by anything, but it's negative because it's opposite your assumption. And we have positive 3 times distance x. This force 3 still need distance x to be a moment. Nothing else equals 0. Finally, your moment in one side and everything on the other side. So your moment will be positive 24, negative 3x. I am done. Once you are done, I believe 90% of your problem is done. Please try to do your best to derive a correct equation for moment as a function of x. It's very simple. First step, go ahead and get your reaction. Second step, assume distance x from your left and stop at any location. Do your cut and use the left part. So draw your free body diagram. At your cut, we have normal, we don't care. We have shear, we don't care. We have moment, would like to make this member to smile. And put your reactions and put your distance x. Go ahead and take a moment at this cut. So I can derive equation for everything, including your moment. Put your moment in one side and everything on the other side. You can find an equation for a moment, for your moment as a function of x. Okay, then it's a piece of cake, just mathematic steps. Second derivative of y related to x equal m over ei. Put ei outside the equation of your moment. 24 negative 3x. Go ahead and do integration 2 times. First time, you can get dy by dx, which you called theta, equal 1 over ei. It's constant, so I don't care. 24 to be integrated relative to x will be 24x. Negative 3x to be integrated will be x squared divided 2. And remember, you did integration, so we have constant of integration, C1. Can you do it one more time? Yes, one more time. Integration for dy by dx will be y. Your y will equal 1 over ei. 24. Integration of x will be x squared divided 2. Negative 3 divided 2. 3 divided 2 is constant. X squared, integration of x squared will be x cubed divided 3. Integration of C1 will be C1x. And one more integration, that means we have one more constant, C2. I need to figure out the values of these constants, C1 and C2. That means we have something called boundary conditions. Please go back to your beam. What type of support do you have? What type of support do you have? We have hinge support. We have roller support. We have hinge support. We have roller support. Go back to your boundary condition. If you have hinge support, deflection only equals 0. If you have roller support, deflection only equals 0. Deflection means Y. Deflection means Y equals 0. That means we don't have any boundary condition related to theta. Why? Because we don't have fixed. Your beam, your current beam, has only hinge and roller. Okay, so where is the hinge? This hinge at x equal what? This hinge at x equal 0. So first boundary condition, I can say at x equals 0. That means I am sitting at support A. Your deflection equals 0. Okay, where is the equation for Y? This is the equation of Y. Go ahead. Y equals 0. Equal 1 over EI. Your distance x is 0. So 24 times x squared divided 2 will be 0. Minus 3 divide 2 times x cubed divide 3, your x is 0. So this term will be 0. Plus C1 times 0 will be 0. Plus C2. Finally, I can cancel 1 over EI by 0. Finally, I can say, hey, C2 equals 0. Okay? Second boundary condition. Anybody can tell me the roller support, this roller support B, where the roller support at x equal this roller support. Remember, your x is starting from left. So I need to start from left to reach to point B, to roller support. So I think x will be equal 8 meters. So I can say the second boundary condition at x equal 8, your deflection equals 0. Hey guys, this beam has only hinge support and the roller support, and your x assumed from left. To reach the first support, your x will be 0. And deflection at this point equals 0 because it's a hinge. To reach to this roller support, I need to walk distance x equal 8. At this location, your deflection also equals 0. Hinge or roller, you are talking about deflection. Why? If you have fixed, you can talk about deflection and rotation, like we did in the last problem, last lecture. If you have fixed. Any question for this point? Because this point is very important. Any questions? Thank you, bro. Any question for this point?
Dr. Raymond, before we move on, can I ask you a quick question or two?
Yeah.
So first, when you do your cut, you only worry about moment. That's it.
Yes.
And then also when you, sorry, go ahead.
No, go ahead.
And then also when you do the boundary conditions, you only do them at supports.
Yes. Yes.
Alrighty. Thank you.
Yeah. For boundary condition, my concern is where are your supports and what are the types of your support. For moment, for your cut, actually we have normal, we have shear, and we have moment. We don't care about normal. We don't care about the shear because will be cancelled. My concern is my moment. Okay. So at x equal 8, y equal 0. Be careful. Y equal 0 equal 1 over EI 24 times x square 8 square divide 2 minus 3 divide 2 x cube will be 8 cube divide 3 plus C1 times x times 8 plus C2 is 0. I think I can cancel this term by 0. So the only unknown in this equation is C1. So I can figure out what is the value of C1 quickly. So 24 times 64 divided 2 minus 3 times 8 to power 3 divide 6. All of these values divide 8 will be negative 64. So finally, I can figure out what are the values of constant C1 and C2. So I will rewrite this equation that C1 became negative 64. And I can cancel this positive. And C1 is negative 64 and C2 equals 0. Any question? So finally, I can rewrite this equation here. Theta equal 1 over EI 24 minus 3 x squared divided 2 minus 64. Y equal 1 over EI 24 x squared divided 2 x cubed divided 3 minus 64 x. Here is your final equation for y, for theta and y. Once you did your constant and you get the final equation for theta and y without any constant, all of them are function of x, I can go back to the original problem and see what is the required or what are the required. We need a slope theta at A and theta at B. Anybody can tell me point A at x equal what? 0. Point B at x equal what? 8. So at x equals 0, I can say theta at A equal 1 over EI. I'm using this equation. X equals 0, so 0 minus 0 minus 64. So your final answer will be minus 64 divide EI. Your rotation is negative. That means it's clockwise. at x equal 8, that means x equal 8 means you are here at B. So theta B will be the same equation, but x equal 8. So 1 over EI, 24 times 8 minus 3 times 8 squared divided 2 minus 64. Your final answer will be, just a moment, 24 times 8 minus 3 times 8 squared divided 2 minus 64. Your final answer will be positive 32 divided EI. Positive means counter clockwise. So I am done with theta at A, theta at B. So I am done with the slope at A and the slope at B. We are looking for deflection. Deflection means Y. Where? I'm looking for deflection where? At midspan. Midspan means at the intermediate distance between this support and this support. Anybody can tell me this point, which is midspan, at x equal what? Yes, at x equal 4. Remember, your x all the time is measured from your left. So I need to walk from this left to the midspan. So I need to walk x equal 4. So I will say at x equal 4, deflection y equal. So I will use this equation for deflection. Y equal 1 over EI 24 times x, which is 4 squared, divide 2, minus 3 divide 2, x cube, 4 cube, divide 3, minus 64 times 4. So I can figure out the final answer, 24 times 16 divide 2, minus 64 times 4. Your final answer equal negative 96 divide EI. Anybody can remind me what does it mean by negative value for Y? Negative value for Y means this point moved down. This point moved down. Is go back to your sign convention. If you have positive value of Y, this point moved up. If you have negative value, this point moved down. For theta, if your value is positive, counterclockwise. If your value is negative, clockwise. Thank you, Ehab. Thank you so much. Okay. Remember, please read your problem carefully. I am done with the slope at A, slope at B, deflection at midspan. I still need to draw a curve, which called elastic curve. What is the new shape of this beam after deformation? Can you look to me, please? Here is the original shape of this beam. We have support here, A. We have support here, roller, B. Anybody can remind me the value for theta at A? I don't care how much, but it was negative. That means it's clockwise. Theta at B, it was positive, which means counter. Clockwise. deflection at mid-span, I don't care how much, but your value is negative. That means this point moved down. Okay, let's start. I will start with the deflection. Point A will not move. Point B will not move. The point at mid-span moved down by deflection. Want the value equal 96 divided EI. I don't care about the value, but my concern is where? The direction, down or up. So this point moved down. Okay, one more thing. So the first step, I put my deflections. Second step. The original shape of slope at any point is a horizontal line. So the original rotation at A before any load, it was a horizontal line. But after deformation, this line will rotate clockwise. This line will rotate clockwise. Can you rotate this line clockwise? Yeah. If this line rotated clockwise, it will be like this. And this rotation, theta at A. The original shape of slope at B is a horizontal line. Oops. The horizontal shape of a slope at B is a horizontal line. But the new rotation is positive, so which is counterclockwise. Can you rotate this line to be counterclockwise? Yeah, this line to rotate counterclockwise will be like this. Because this line rotates like this. And this line rotates like this. So this one is clockwise, this one is counterclockwise. And this rotation, theta at B. Finally, can you draw a curve connecting between this point and this point and this point, and the tangent to this line and this line? Yes, your final curve will be like this. This curve called elastic curve. So can you understand right now what does it mean clockwise or counterclockwise? Yes, clockwise means, counterclockwise means the original shape of your tangent is a horizontal direction. After deformation, your tangent probably will rotate clockwise direction if your theta equal negative. Or probably your tangent will rotate counterclockwise if your theta is positive. And if your deflection is positive, your point will move up. If your deflection is negative, your point will move down. One more time. We have another example. Last one. We have beam fixed at one end, B, fixed at this end only, and free at A. And we need to figure out what are the slope theta, what is the deflection Y at the cantilever tip. What is the meaning of cantilever tip? I think point A. The problem means point A. It is a cantilever tip. Point A. It's given. Okay. And then draw the elastic curve. Okay. Let's start. Our first step, reactions. I think we have a vertical reaction here. We have a horizontal reaction here. And we have concentrated moment here. If you apply summation f of x equals 0, the horizontal one will be 0. If you apply summation f of y equals 0, the vertical one will be 6 kilonewton. If you take moment at support B equals 0, assume this direction is positive, I think this moment will be 18. So I can figure out the reactions. Chapter 2. Second step. Assume a distance x. Be careful. Distance x from your left. I don't care where is my support. It's not my issue. I have to assume my x distance from left. Here is the left side. Please go ahead and assume a distance x and did your cut. And I will use the left part. Please go ahead and draw your free body diagram. Your free body diagram looks like this. I have here a vertical force, 6 kilonewton. At your cut, we have normal, we don't care. We have shear, we don't care. And I have a moment. This moment would like to make this member to smile. But remember, this distance is x. Anything else? I don't think so. Then I can say summation moment at this cut O equals 0 and assume this direction is positive. If you take moment at this cut O, I can cancel normal and shear, but I still have moment. And we have positive, the same direction also, 6 times distance x. I believe we don't have anything else. Equals 0. Put your moment on one side and everything on the other side, so your final moment equal negative 6x. That's it. That's it. Keep going. Second derivative of y related to x equal m over ei. So 1 over ei outside, your moment is negative 6x. Please go ahead and do your integration 2 times. First time can give you dy by dx, which is called theta, equal 1 over ei negative 6 x squared divided 2, and we have c1. One more time. If you integrate this equation one more time, you can get y equal 1 over ei negative 6 divided 2. We have x squared will be x cubed divided 3 plus c1x plus c2. So we have 2 constants, c1 and c2. That means we have to apply for something called boundary conditions. Boundary condition means I have to search for my support. Where are your supports and what are the types of your support? I think we have fixed support only. We have a fixed support. If you have fixed, we don't have deflection. We don't have rotation. But can you remind me? I would like to reach to this deflection. I'm sorry, I would like to reach to this fixed support. So at x equal what? Your x is starting from left. So I think at x equal 3, I can reach my fixed. So I can say at x equal 3, your theta equals 0. I can say at x equal 3, your deflection equals 0 because we have fixed support. And if you go back, if you have a fixed support, your deflection is 0, which is y, and your rotation is 0, which is theta. Okay. Let's go. I will start with theta. So I will use this equation. Theta equals 0 equal 1 over EI minus 6 times 3 square divide 2 plus C1. I think 1 over EI will be cancelled by 0. The only unknown in this equation is C1. So C1 will be how much? I think it will be positive 27. Yeah, will be positive 27. Go ahead. And at x equals 3, y equals 0. So I will use this equation. Y equals 0 equal 1 over EI negative 6 divide 2 times 3 cube divide 3 minus or positive, I'm sorry, C1, which is 27 times 3x plus C2. I think this one will be cancelled by 0. The only unknown in this equation is C2. So I can figure out what is the value of C2 with calculator. We have negative 3 times 27 divide 3 plus 27 times 3. Your value will be negative 54. So finally, I can write my equation theta equal 1 over EI negative 6 x squared divide 2 plus C1, which is 27. And your y equal 1 over EI negative 6 divide 2 x cubed divide 3 plus 27 times x plus C2, which is negative 54. I can derive anything using these two equations. Just give me what is the value of x, I can give you what is the value of theta or what is the value of y. So please go back to your problem. We are looking for theta and y at point A, tip of the cantilever. So point A, at what distance? I am starting from left and I would like to reach to point A. So what is the distance x? I think your distance x is 0. So because you're starting from left and your point on the left, so x equals 0. So I will say at x equals 0, I can figure out what is the value of theta at A equal 1 over EI 0 plus 27. Your final answer will be positive 27 divide EI. Positive means counterclockwise. Deflection at A at x equals 0 equal 1 over EI, 0 plus 0 minus 54. Your final answer will be negative 54 divide EI. Negative deflection means your point moved out. Your beam originally looks like this. Fix it here. Here is A, here is B. Let's start with the deflection. This point didn't move. It's support. This point moved down. Equal negative 54. I don't care about how much, but negative means down. So this point became here. Second step, rotation. I think the original rotation or the original slope at point B is horizontal. And still horizontal because theta at B equals 0. Your boundary condition at B, y equals 0 and theta equals 0. So your slope will be horizontal. The original slope at A was horizontal, but your value is positive, so it's counterclockwise. Please go ahead and rotate this line counterclockwise. So I think it will be looks like this. Rotated counterclockwise theta. Finally, I would like to draw a curve connecting between this point and this point, tangent to this line and the tangent to this line. So I think your curve will look like this. Please draw elastic curve, smooth curve. This curve called elastic curve. Guys, I would like to remind you for something very important. Do you remember last time when I solved this beam on Riza? Do you remember? Finally, I showed you a curve looks like this. Do you remember? Do you remember this curve? Yeah, this is what we did right now. This one called elastic curve. And if you remember, the deflection at this point was negative, so it's down. At this point was negative, so it's down. If you try to figure out what is the rotation, rotation here will be clockwise, so it will be negative. Rotation here is clockwise, so it will be negative. So what we are doing right now, we are drawing elastic curve. And this elastic curve must follow your final answer. Based on your value of theta, your values of deflection, I can figure out the new shape, the deformed shape of your structure. Based on the final values of your theta and the deflection, I can figure out the new shape or the deformed shape of the beam. Any question? I will wait a moment for any question. I think this method is the simplest method. I think the problem cover this method in the exam must be done 100%. Because your problem in the exam will looks like the same. We don't have any ideas. Your problem in the exam will be one of them. Simply supported beam, that means we have hinge or roller or beam with fixed support from one side. Nothing else except these two shapes. Nothing else. So we don't have many ideas in this topic or in this method, double integration method. So you have to guarantee this problem in your coming exam. will be very easy. Any question? Any question? So please try. I'm going step by step. Right now, until this moment, your coming exam, you will have problem, sketch without calculation, influence line for reaction. Second problem, complete problem on influence line. One looks like your homework number 6. Exactly. You have a beam, you need to sketch influence line for reaction and tell me where can I put my dead load, where can I put my live load. That's it. Then double integration method. The problems like we did today or last time. So one problem, 2, 3 problems. Until this moment, 3 problems in the coming exam. We still have 2 more. Conjugate beam method and virtual working. So I'm walking step by step, slowly. But remember, my philosophy in teaching, because I hope this is not the last year with you. So we still have 1 more year. So my philosophy in teaching, I have, and I can say who is. I have a student at this level. And I have a student at this level. I'm teaching at this level. So I'm so sorry for this student. And this student must go up to our levels because I cannot teach in this level. I cannot. If I do, I'm wasting and I'm destroying this student. So please try to do your best. Any student should follow this distribution. The majority should be here at my level of teaching. And we have some at high level, and I still have some at this level. So please try to do your best. Anybody write anything? Okay. Let's start our new topic. Actually, I will not go through this method in more details, but just a quick comment. Conjugate beam method will do and will give you the same values. What is the value of theta at a point? What is the value of deflection at another point? But this method can talk about a more complicated beam. What you mean by more complicated? Like this one. This one is more complicated. We have fixed. We have roller. We have beam connection. It's more complicated. Like this beam. This one is more complicated. It's not simply supported. We have hinge, we have roller, and we have something called cantilever. So this beam is more complicated. So this method will help us to do the same like we did before. What is the value of theta? What is the value of deflection? But for more complicated beam. We have some step. 1, 2, 3, and the 4 steps. We have 4 steps. We need to follow them. So I will cover today the first 2 steps. You have to draw your moment, bending moment diagram. First step, you have to draw bending moment diagram of your beam, but with a new method called superposition method. And these diagrams will be given in the exam. You don't need to remember all of them. These diagrams will be given. If you have beam with concentrated load B, your bending moment diagram will be a triangle. I'm sorry. Will be a triangle. And this value of moment equal P, the applied load, time distance A, time distance B, divide L. If you have uniform distributed load on simply supported beam, simply supported means between hinge and roller, your moment looks like a parabola, and your maximum value here, W, L square divide 8. As I told you, these diagrams will be given in the exam. You don't need to remember, but at least to be familiar with these shapes. If you have concentrated load at any location, your moment will be a triangle. And remember, the vertex of this triangle underneath the location of your moment. And the value of this moment will be PAB divide L. If you have this uniform distributed load, your moment will be parabola. Your value here will be WL square over 8. If you have concentrated moment at one end of the beam, your moment will be like this. And 0 at the other side, and you have a triangle. Hey guys, I covered this one before, I remember. If your moment at this location like this, your value will follow the head of the moment. That means if your moment looks like this, your value will be like this. So based on where is the head of the arrow, if the head is down, your value is down. If the head is up, your value will be up. Okay, and on the other side, we don't have moment, so it will be 0. We have 2 cases, this one or this one. These 3 cases, if you are talking about simply supported, you have hinge on one side and roller on the other side. If you are talking about cantilever, which means fixed on one side and free on the other side, if you have concentrated load, your moment looks like this triangle, P time L. If you have uniform distributed load, your moment will be parabola like this. And your value here will be W L square divide 2. If you have concentrated moment, your moment value will follow the head of the air, will be down and will be constant. Also, these diagrams will be given in your exam, but you need to be familiar. If you have cantilever with concentrated load, your moment looks like triangle, down. For one reason, because P time L will be like this, so the head of the arrow is down. If you have uniform distributed load, your moment looks like a parabola, and this value WL square over 2. And if you have concentrated moment at the end, your value will be m down because the head of the arrow is down, and this value will be constant. But if you have simply supported beam with cantilever, okay, this case, this shape looks like this one exactly. That's right. So your moment on this part will be like this. This shape with the concentrated moment looks like this one exactly. So your moment on this part will be constant like this. This part looks like this one exactly. So your moment here will be like this. Then go ahead and connect between the final value here with 0, with 0, and with 0. This one will not given in the exam because these shapes looks like this one. These shapes looks like this one. These shapes looks like this one. Okay, but sometimes we have a beam with concentrated load on this cantilever, and we have uniform distributed load between the roller and the hinge support. So that means we have this case and this case at the same time. What should I do? We need to do something called superposition. Superposition means I will assume that your beam with this concentrated load only. And then I will assume this beam with this uniform distributed load only. So if you have this case with concentrated load only, I think your moment looks like this. And because this shape will be like this one. And I will connect between this value, which is P times L1, because this distance is L1. And I will connect to 0. Then, if you have uniform distributed load, your moment will be parabola. Well, looks like this one. And your value will be WL squared divided 8. So finally, the final moment for this beam will be like this. This shape, which is coming from this concentrated load only, and this shape, which is coming from the uniform distributed load only. Because both of loads are there, that means we have two diagrams, one parabola and one triangle. This moment can be called bending moment diagram, but with a method called superposition. Superposition means you can assume each load alone on the beam and draw a diagram. And we have another load, draw another diagram. We have another load, draw another diagram. Then all the loads are there. That means we have many diagrams at the same